Hello and welcome students in lecture number 5. This is lecture number 5 of angle and its measurement. We are solving this question number 13. That is, find the degree and radian measure of exterior and interior angle of a regular pentagon, hexagon, septagon and octagon. Pentagon is a polygon having 5 sides. Hexagon is polygon having 6 sides. This is polygon with the 7 sides, and this is polygon having 8 equal sides. Why do I say equal? Because they have clearly specified it is a regular. Okay, it's a regular pentagon, hexagon, heptagon and octagon. Okay, so students, we will begin with, I will solve one problem for you, that is hexagon. So let me first draw a regular hexagon. Now to draw a regular hexagon, see, it is not going to be easy drawing a regular hexagon. Remember one thing, you don't have to actually draw the diagram for solving this problem. You can solve the problem without drawing the diagram. I'm drawing it because I just want you to have a clear picture of what we are doing. You, as such, you don't have to draw the diagram. Remember that. So if the idea is clear, you can easily solve this. You can easily solve this problem without the diagram. Diagram is not necessary. I'm doing it because I want you all to have a clear picture of what we are doing. So see here, we have a regular hexagon here. It's actually not easy drawing one, but then still I will try my best. It is not easy drawing Okay, I will repeat once again, students. See this diagram which I have drawn here. For actually solving this problem, you need not have to draw a diagram. I must tell you that I drew the diagram, which is a very close to a perfect looking diagram. The only reason being I wanted you all to have the clear picture of what we are doing. So here you have a hexagon. Let me name the hexagon as, I will name it as, the hexagon is A, B, C, D, E and F. This is regular hexagon. Now, this regular hexagon has 6 vertices. It has 6 vertices, and see, there will be, it has 6 vertices, it has 6 equal sides, and there will be 6 interior angles. You can check here. See, these are interior angles of the regular hexagon. They are interior angles. So what I'll do is I will name each one of interior angle as X. I will write, see, I write one angle as X. So this all angle will become X. So that is X. Okay, so here, and then remember that there will be 6 exterior angles. Now, what are exterior angles? That we will follow in order. Okay, so that we will have to follow in order. So see here, if I extend this way, okay, so here I got one exterior angle. You can check. See, this is one exterior angle which I got. Okay, I'll do one thing. I will use the white color only because then it will have a uniformity. So you can see this is one. If I extend it, then I got an exterior angle here. And then see, this is another exterior angle that I got. So there will be 6 exterior angles which we will have. 6 interior angle and 6 exterior angles we have. At every vertex you have an exterior angle. At every vertex, you have an exterior angle. Now remember that as these all interior angles are equal to each other, so as the exterior angles. The exterior angles will also be equal in measure. Okay, so if I take one of them as y, remember all the exterior angles will become equal to y. Okay, I once again say that this diagram is not necessary when you are solving a problem. Okay, whether it is because see, but only thing you have to understand is that since I'm solving problem second, which is for hexagon or regular hexagon I'm solving for, so everything is 6 in number. Everything is 6 because I'm solving for regular hexagon. So you have everything 6 in number. If you are solving for pentagon, then it will all will be 5. Like you will have 5 interior angles, 5 exterior angles, and 5 equal sides. Okay, so that's the only difference, nothing else. Septagon, it will be 7, and octagon, it will be 8. Okay, so uh, see now how do I what is the question? The question is find the degree and radian measure of exterior and interior angle. We have to find the value of x and y. So here I will start my solution with by writing. I will start my solution by writing let the interior and exterior angles of a regular hexagon of a regular hexagon be x and y respectively. This is my assumption. Okay, so I took them as x and y. Now remember students, there is a property for regular hexagon. And what is that property? The property is sum of all the exterior angles of a regular hexagon will be equal to 360 degree. I repeat again. Sum of all the exterior angles of a regular hexagon. Sum of all the exterior angles. So see this. All these exterior angles of a regular polygon. Here it is hexagon. Whatever the polygon may be, hexagon, heptagon, octagon, nonagon, whatever it is, the sum of all exterior angles will always be equal to 360 degrees. So this property I will write here. I write here, we know that, see here what I'm writing. We know that sum of all exterior angles of a regular polygon equals to 360 degree. What is it equal to? It is equal to 360 degree. Now students understand. Sum of all the exterior angles. How many exterior angles I have? I have 6 exterior angles and each one of them is y. So it is y plus y plus y plus y. 6 times you add y. So what you'll get? You'll have 6y equals to 360 degree. So y is equal to 360 upon 6. That is equal to 60 degree is your y. So you got y as 60 degree. Now you can understand that this x and y, they are supplementary angle. The sum of these two angles is equal to 180 degree because they are linear pair angles. You understand x plus y equals to, you can check, see this x and this, sorry, this y and this x, they are linear pair angles. So here what I will do is if I'm adding x and y, what I'm going to get? I'm going to get 180. So I will write here also x plus y equal to 180 degree. You can check from the diagram. Okay. So here each one of anywhere you check, if you add y with x, what do you get? You get 180 because these two angles are made on a straight line. You can check they are made on a straight line. See, they are made on a straight line. So here anywhere you can check, see this x and y, if you add, they are going to give you 180 degrees. So here I will write, since also x plus y is 180 degrees, so x plus 60 degree is 180 degree because you got the y value as 60 degree. So you got x equals to 120 degree. Now see, you got x and y both in degrees. Now what do they want you to do? They want you to get the radian measure also. We have to get the radian measure as well. So for getting radian measure, what I will do? I will change this into radian. I will write we can write see here, I can write y is 60 degrees, so I can write this as 60 into 1 degree. You know, 60 degrees 60 times of 1 degree. And what is 1 degree? It is pi radian upon 180. So y equals to, you got 60 into pi radian upon 180, which will get you pi by 3 radian. Pi by 3 radian you got. And on the same line, you will change this x into radian. So for changing x into radian, what you will write? You will write here and x is 120 degree, which is same as 120 times 1 degree, and 1 degree is pi radian upon 180. So 120 pi radian over 180. This gets you 2, and here it gets you 3. 62s are 63s are. That is 2 pi by 3 radian. Okay. So you will write therefore, final answer you can write therefore the radian and the degree and radian, radian measure of interior angle are, the degree and radian measure of anterior angle are, see, 120 degree and 2 pi by 3 radian. Then you will write the next, what? The degree and radian measure of exterior angle are, that is 60 degree and pi by 3 radian. 60 degree and pi by 3 radian. This completes the solution. Now, if it was 5, my dear students, if it was pentagon, what would have happened? Very simple, you understand. If it was pentagon, what would have happened? Nothing much. If you have pentagon, you will give the heading as regular pentagon. And then this will be your assumption. Do we have to draw the diagram? No, not at all. Diagram is not necessary. Okay, this is regular hexagon. If you want to imagine that diagram, remember that it will be a regular pentagon. It will have 5 interior angles and 5 exterior angles. So, but then, you know, this formula will still remain the same. And what is it? The sum of all exterior angles of a regular polygon is 360 degree. So since there we will have 5 exterior angles, we would be writing 5y. We would be writing y plus y plus y plus y plus y, 5 y's. You add all the 5 exterior angles, you'll get 360 degree. So that will get you 5y equals to 360 degree, and therefore it will be, y will be equal to 72 degree. Accordingly, the things will change. So when y you will have 72 degree, x will be accordingly, you will have to find. So you can find in that case, x will be 108 degree, and then you can go for the rest. Okay, I hope you all have followed it. What you can do is you can play the video once again in order to understand it well. Okay, so we have completed, till here we have completed one part of angle and its measurement, that is the different types of angles. After defining the directed angle, that is an angle which will have the positive and the negative direction. The angle will be positive, the angle will be negative. Then we did all different types of angles, and then we saw how to measure angles. We learned the 2 different system of measuring angle. That is, one is a degree system, which is sexagesimal system. The other is radian system, which is circular system. And after that, we solved problems based on those 2 systems. Okay, some good problems we saw. That comes to end of one subtopic. Now, in this chapter, the next subtopic is on your screen. And what is it? It is arc length and area of a sector. So the first thing that we have to learn here is what is a sector. Remember students, whenever you say sector, it has got relation with a circle. So it is not said as such, but then sector of a circle. It goes without saying. What is it? It is sector of a circle. It is sector of a circle. But then it goes without saying. We don't have to say every time sector of a circle. If it is said, a sector has to be a circle. There is a circle, and then only we got the sector of that circle. Similarly, if we have an arc, remember it goes without saying, it is arc of a circle. It is arc of a circle. But once again, as I said, in case of sector, we do not mention that it is of a circle. It is understood. Same way, same is the case with the arc. It is understood that it is arc of a circle. Okay. So what I'll do is I will take a reference circle. So here I have a reference circle, and this circle has center O. Let the center of the circle be O. Now I take, as usual, I will take initial arm, that is, as you know, now I am intending to form an angle. I am intending to form an angle. So I get an initial arm here. I take an initial arm, and that initial arm is say OA, for, or say the initial arm is OP for a change. For a change, we will have here OP as initial arm. This point is P. So OP is initial ray or initial arm, whatever you say. Okay, now what happens? You know, there will be a rotation. There will be a rotation of rotating arm, and say that is OQ. Now the rotation takes place, and suppose you stop here. You stopped here, and this point you call as OQ. This point is Q, and you have the terminal arm as OQ. This is terminal arm. So you write here OQ is the terminal arm or terminal ray. Terminal arm or terminal ray. Now see, when this happened, you know, there was a rotation of the rotating arm, so that gave you an angle theta radian at the center. It gave you an angle theta radian at the center. Now here something is very specific that I want you all to make a note of. I want you all to make a note of this very specific thing, and it is that I said that angle made at the center is theta radian. I could have said theta degree, or I could have simply said theta, but I made sure that this angle I write in radian. Okay, so this is a very important condition that you all have to follow, that it is the angle is in radian. The angle measured here, the angle which you have as a central angle, this theta radian is the central angle. So I write here angle formed at the center of the circle. I write here angle formed. I write angle formed at the center. Angle formed at the center of the circle. Okay, circle is theta radian. It is what? It is theta radian, and I made it deliberate theta radian. Okay, and in the beginning what I will write here consider or reference circle with radius r. Let me write here consider or reference circle. This is a reference circle. Consider a reference circle with radius r. R is the radius. So from O to P is R, from O to Q is R. And what is the central angle? Theta radian is the central angle. Okay, theta radian is the central angle. Students, you don't have to be much worried about this theta radian. I will make it clear. Suppose you have some angle and that angle is say 1.5 radian. Okay. So 1.5 radian, what does it mean? It is 1.5 is the magnitude and it is measured in radian. Like suppose you say the angle is say you say 73 degrees. So you measure some angle and you write 73 degrees. In that what you say is that 73 is the magnitude and it is 1 degree, which is the unit. So 73 degrees are actually 73 times of 1 degree. Likewise, 1.5 radian. So as you can measure an angle in degrees, you can definitely measure an angle in radian. So here I measure the angle in radian. This is theta radian. Okay, and you will not, here I'm not writing the angle in degrees. I'm writing the angle in radian. That is something important. I could have written the angle in degrees also, but the condition here is we will write always the angle in radian. So see, whenever we are going for arc length or we are going for area of a sector, we will always write the angle in radian. Okay. Now see, when you have done this much, what you end up with is a sector. See, here you are getting a sector. I am going to shade that. This shaded region is known as sector of a circle. And this sector is known as sector OPQ. What is it known as? It is known as sector OPQ. So this is sector OPQ formed. Now this sector OPQ, the shaded region, I write here, the shaded region in the diagram is sector OPQ. It is sector OPQ. Sector OPQ. Okay. Now this sector has got three boundaries. I want you all to be very focused, very watchful. It has got three boundaries. Now, what are those three boundaries? I want you all to see. See, it has three boundaries, the sector. One boundary is this radius. See, one radius. This radius is one boundary. The another boundary is this radius, the second boundary. And the third boundary is this arc PQ. What is that third boundary? The third boundary is arc PQ. What is the third boundary? The third boundary is arc PQ. So the two boundaries are straight line and the third boundary is arc. This is arc. And what is the central angle? The central angle is theta radian. Now see here. Many a times it is also referred that this central angle is subtended by the arc PQ. Why it is said, I will tell you. It is because the two arms of the angle are OP and OQ. See, the reason for we saying, many a times it is said that arc PQ subtends angle at the center theta radian. It is said that this arc subtends the angle. Now, what is the reason for that? The reason is very simple. The reason is simple because see, the two arms of the angle are, one is OP and the other is OQ. Now this OP and OQ are two arms, and this PQ is the arc. So it is quite obvious that we can say that it is PQ which is making angle theta radian at the center. It is PQ which is making angle theta radian at the center. I'm just telling you these are different ways of discussion. Now what I will do here is, see, I will write here let area of sector OPQ equal to A. That is my assumption. What is A? A is the area of the sector. This is, I assume, let it be equal to A, area of the sector. Okay, and I assume the next one as the length of the arc PQ. I write let length of arc PQ, this arc, okay, arc PQ be equal to S. These are all usual notations, okay? So now remember students, you have the area of the sector. What is the area of the sector? It is A. And you have S, which is the length of arc PQ. You remember arc will have length and the sector will have area. Now I'm writing the formula. These two formula you are going to learn by heart. Okay, these two formulae you will learn by heart. The first formula I write is for the, I will write the first formula for the length of the arc, and that formula is S equals to R into theta. It is S equals to R into theta. You just have to multiply R with theta. R multiplied with theta will give you the length of the arc. Okay. Then I will go for the area of the sector. See here, I will write the formula for area of the sector. What is that formula? That formula is also very simple. And see, that formula is A equals to 1 upon 2 into R square into theta. 1 upon 2 multiplied by R square theta. You know what is R? R is the radius of the circle of which the sector area you are interested in. R is the radius of the circle of which the sector area you are interested in. Okay, and what is theta? Theta is the magnitude of the central angle when it is formed at the center. Okay, so these two formula you have to learn by heart. Now see here, I write a note here. That note is very important. So let me now write the note. Here I write note. See here, in above two formulae, the angle used is theta. The angle used in above two formulae, the angle used is theta. Okay, now see what I will write next. This angle is measured, it is measured in radians. It is measured in radians, and in the formula we use the magnitude, of the angle. We use the magnitude of the angle. What does it mean? See, it means you can check. You all can check here. See, the formula is S equals to R theta. Have I written radian here? Tell me. Have I written radian there? No. Have I written S equals to R theta radian? No. I have written only theta. So what does it mean? It means that the central angle has to be measured in radian, but in the formula, you write only the magnitude, not the radian unit. It means suppose the central angle you found, theta radian, you found to be, you found it to be, say, 3 radian. If theta radian you found it to be 3 radian, then in the formula for theta, you will only write 3. What you will write? You will write 3. Why? You don't have to write radian here. You have to write only the magnitude. Okay, so that is true for both the formula. See, you have to measure the angle in radian, but in the formula you use only the magnitude. You don't use that radian symbol. I hope it is clear to you. You will please make a note of this, because this, based on this, we are going to solve a number of problems. This is a question based on the formula that just now we did, that is S equals to R theta, and the area of the sector is A equals to half r square theta. Okay, S equals to r theta, and area of the sector, that is half r square theta. Here we have a question: find the length of an arc of a circle. Find the length of an arc of a circle which subtends an angle of 108 degree at the center of the circle if the radius of the circle is 15 centimeter. So this diagram is the part of the answer. Okay, so here I have a circle, and at the center of a circle, the angle subtended by an arc, you can check the arc is AB. At the center of the circle, the angle subtended by arc is 108 degree. So the angle subtended by arc is 108 degree. Which arc is subtending this angle? The arc is this arc. See, it is this arc which is subtending the angle. I need to find the length of this arc. Okay, I'll go for the formula. The formula says S equals to R theta. So here I'll write, we know that S equals to R theta. S equals to R theta. Now remember, students, the condition is this theta which you are using in the formula, this theta is required to be the magnitude of radian measure. This theta is required to be the magnitude of the radian measure. So here what I will do, I will change this degree angle into radian first. Okay, so I write here theta radian is 108 degree. What is theta radian? In this formula, the derivation, it is not done. I did not derive it for you. But then see, in the derivation, the angle has to be theta radian here, but the formula will use only the magnitude. So what is theta radian? Theta radian is 108 degree. Theta radian is 108 degree. Now see, next what I do. 108 degree, I can write 108 times 1 degree, which is equal to 108 into, what is 1 degree? It is pi radian upon 180. Now you have the table of 36, 36 threes are, 36 fives are. So what you got? You got theta radian as, so here you have theta radian as 3 pi by 5 radian. Now you can understand. Theta radian is 3 pi by 5 radian. So if theta radian is 3 pi by 5 radian, what is theta? What is theta? Therefore, theta will be 3 pi by 5. That's it. Theta will be 3 pi by 5. And what is the radius given? Radius is 15 centimeters. So I will write, therefore, S equals to R theta. In place of R, what do I write? I write 15 centimeters. And in place of theta, what do I write? I write 3 pi by 5. Okay. So this gets you 5 ones are 5, 5 threes are. So this gets you S as 9 pi centimeter. This is the way you write the solution of the question. Okay. Fine. Now, students, I will add one more part to it, though it is not asked in the question, but if it was, suppose I ask you the area of the respective area of the corresponding sector. If they ask you the area of the corresponding sector, so what is the corresponding sector? This becomes the corresponding sector. See, this is the corresponding sector. I have to find the area of this sector. Okay. I have to find the area of this sector. What will I do? I will use the formula. What is formula? Area is half r square theta. Area is half r square theta. I will write here area of the sector. First of all, I will assume this as A. So area sector AOB, it's AOB sector A, O and B, remember. So area sector AOB is, I'll write half r square theta. Once again, remember students, in this formula where you are writing theta, what is that theta? Is that theta the degree magnitude? No. This theta here is the magnitude of the radian measure. That is, this has to be in radian, and then you write the magnitude, which we have already done. Okay, see, we have already done that. We have converted that degree into radian measure, and then theta is 3 pi by 5. So here I would write, so the area I will get 1 upon 2 r square. R square is, see, 15 centimeter square, 15 centimeter square. And then what is theta? Theta was 3 pi by 5, 3 pi by 5. So you can now do the calculation. This is 15. So 15 square it is. So 15 into 15. So what will happen is, you know, I'll do one thing. I'll first simplify here and then write the answer. So see, 15 into 15 I will get into 3 pi upon 5, and here I have 1 by 2. So this is 5 on the 5, 5 3. You got that? So this will be, you got 9, 135 pi upon 2, 135 pi, 135 pi upon 2. I'm sorry, not upon 5. It is upon 2. 135 upon 135 pi upon 2 centimeter square. Why centimeter square? Because see here, it is 15 centimeter and square. So it is this which I will get. So the final answer I get is 135. I get here 135 pi upon 2 centimeter square. This is area of the sector. It wasn't asked, but I just added because it can be asked in some other question. So very good. The next question is, the radius of a circle is 9 centimeter. Find the length of an arc of this circle which cuts off a chord of length equal to length of radius. Okay, this question is quite interesting, but this question needs to be first understood clearly. If you understand the question clearly, you can answer this very easily. See, the radius of the circle is 9 centimeters. So here I would have a circle with the radius as 9 centimeters. So here I have a circle with the radius 9 centimeters. So this is 9 centimeters. Okay. R is 9 centimeter. I write this as O, and here I write as A. What they say, find the length of an arc of this circle which cuts off a chord of length equal to length of the radius. You know, students, they talk about one arc of the circle. See, they talk about some arc of the circle, and what is that arc doing? That arc is, you know, somewhere that arc you have somewhere, and that arc is a very specific arc. You know why? Because that arc, for that arc, if you join the initial and the final point for that arc, you know, somewhere that arc is there. So as you know, students, if you have an arc, you will have its two extreme points. You check this, it will have two extreme points. So now see, suppose this point is P and this is Q. So you have the arc PQ. What is that arc PQ? It is this which is arc PQ. See, this is arc PQ. Okay, so here in the question they have said the arc is such a specific arc which cuts off a chord of the length equal to radius. What does that mean? Okay, I'll explain that. See, suppose you have an arc. Suppose you have one extreme of an arc here, which is P, and the other extreme of an arc here, which is Q. Now, when you join this two extremes of the arc, what you get? You get a chord. What do you get? You get a chord. Okay. So always remember that whichever arc you have on a circle, that arc will always give you a chord, a corresponding chord. Okay, every arc will give you a corresponding chord. So here, the extreme points of arc on the circle, when you join, you get a chord. Now, in this case, this specific chord, whose length they want you to check and find, they are saying that this chord cuts off, this chord cuts off a chord of length equal to length of the radius. That is, the chord, the arc of the circle is making a chord which is having length equal to radius of the circle. So what does that mean? So here, see, the chord, the arc is such that, the arc is such that I take the one extreme of the arc as A. I take the one extreme of the arc as A, and the other extreme of the arc, I take it as B, and I take it here. So one extreme is this, and the other extreme, I take it here. Okay. Now this arc is such that it makes a chord, and the length of the chord is also equal to R. That is what they say. The length of the chord is also equal to R. Okay. So for such a chord, I'm sorry, for such an arc, you have to get the length. See, you have to get the length of this arc. You have to get the length of this arc. Okay. So what I will do is, I will now join B with O. I join B with O. So what do I get? Students, see, this OB, O being a center, OB is also R. OB is also R. Now what do I have? I have an equilateral triangle. So I write my answer here. I write referring to the adjacent diagram. Referring to the adjacent diagram. See here, I write the arc AB cuts off. It cuts off the chord arc AB. You check this. See, can you see the arc AB? Yes, it cuts off the chord AB. It cuts off the chord AB. See, arc AB, when you join A with B, it gets you a chord AB. And what is the length of that chord as per the given question? It's clearly said what? Chord of length equal to length of the radius. Even this chord has got length equal to the radius. So I'll write cuts off a chord AB, and I write here length of chord AB equals to R. Now see here, when I join O with B, I get another radius of the circle. So now I end up with an equilateral triangle. So I write here, therefore triangle AOB is an equilateral triangle. Now you know, students, if it's an equilateral triangle, what will happen? Each of these angles will be 60 degree. Each of these angles will be 60 degree, each one of them. But you know, students, we are not interested in all the angles. We are only interested in the central angle. So that central angle will also be 60 degree. So here what I will write, as usual, see, I want to find the length of the arc, which is S, and I know the formula. What is it? S is r theta. S is r theta, and I know that for this formula, the central angle is considered as theta radian, and from that theta radian, theta is retrieved. Theta is taken. So what I will do is, first of all, I will find my theta radian. So how do I find theta radian? For theta radian, I will convert 60° into radian. So here I write theta radian is equal to 60°. So now convert this degrees into radian. So here I have 60 into 1 degree. And what is 1 degree? 1 degree is pi radian upon 180. So 60 and pi radian upon 180. Okay, this 0 is gone and 6 threes are 18. So you got pi by 3 radian. Okay, so theta radian is pi by 3 radian. Now this gets me the magnitude theta. What is theta? Radian is ignored, and theta, the magnitude, is pi by 3. Now what I do, I will write the formula S equals to r theta. So I write here, since S is r theta, here I write, we know that, okay, we know that S equals to r theta. So S is 9 centimeters, 9 centimeters, and what is theta? Theta is pi by 3. So you get here 3 pi centimeters. You get here 3 pi centimeters. This is the answer. I hope you all have followed it. Okay, the next question here is, find the angle in degree subtended at the center of a circle. Subtended at the center of a circle by an arc, whose length is 15 centimeter if the radius of the circle is 25 centimeters. So here, students, we are given the radius of the circle and the arc of the circle. This is what we are given, and we are asked to find the central angle. So here we have center of the circle somewhere. Now for this circle, they give the radius is 25 centimeter. The radius is 25 centimeters. So here I have 25 centimeter as the radius. Okay. So I write r equals to 25 centimeter. Now for the same circle, they are saying there is an arc, and that arc has length 15 centimeter. The arc length is 15 centimeter. This is what they have said. So here I will have arc somewhere which is 15 centimeter. So that arc, you know, say one extreme is this and the other extreme is this, and this is equal to 15 centimeter. This is the arc. S, what is S? S is 15 centimeter. Now this arc subtends an angle at the center of the circle. This arc subtends an angle at the center of the circle. Which arc? See this arc. When I'm trying to make an angle by rotation, you know, this cursor of my pen, the tip of my pen is tracing a path on the circle, and that is the arc. So they say you need to find this angle. You need to find this angle at the center. I will take this angle as theta radian. What do I take? The angle I take as theta radian angle. Okay. Now I write, we know that. And what is the arc that I have to find? Okay, let me highlight it. Though you all have followed it, but still I will highlight it. Okay, this is the arc that you have to find. Okay, not this thick. The arc is only as good as the circle. So here I will write, we know that. I write here, we know that. I write here, we know that S equals to r theta. S equals to r theta. And what is this theta? Theta is the magnitude of theta radian measure. So S is 15 centimeters, R is 25 centimeters, R is 25 centimeters, and you have theta into theta. So you will have 15 centimeters upon 25 centimeters equals to theta. See, what you got is, you got theta as 3 upon 5. You got theta as 3 upon 5. See, students, you got that theta value, which is 3 upon 5. And you know, this is only the magnitude of that angle which you are working for. So what will be the angle as such, the required angle? The required angle is theta radian, which is 3 upon 5 radian. They want the angle in degrees. So the next step you will write, therefore, the degree angle is 3 upon 5 radian, which you will write into 1 radian. See, 3 upon 5 radian is 3 upon 5 into 1 radian. And then you know what do we substitute for 1 radian? We write 180 degree upon pi. This is for 1 radian in degrees. Now what I'll do, I know the table. I know the table of 36. 36 fives are, okay, 36 into 5 is 180. So 5 ones are 5 and 5, 36 are 180. So the final answer that I get is 108 degree upon pi. This is the final angle. See, if they want, see, we got the angle, which is the central angle, okay? But in case if this question is an MCQ question and you notice that one of the option is given in decimals, then you will write 22, pi is 22 by 7, and then do the calculation, get as such, but this is the answer that we got, and this is correct answer. We got the find the angle in degrees. So we have found the angle in degrees. This is the answer. I hope you all have followed this.